Okay. We're live. How's the audio? We're live. It sounds like the sound is working. How much of a delay do we have on this? Is the question. How much of a delay do we have on this? Is the question. How much of a delay do we have on this? Test. Test. Less than 5 seconds. Okay, cool. There is one human watching. Well, I guess if we're, you know what, if we're gonna be, if we've only got a 5 second delay, we can use the talk in the Discord. So I'm gonna jump into the talk channel of the Discord. How are we doing? Test, test, test. There we go. All right, I'm in the talk channel of the Discord, of the APCS Discord. I think I'm in the talk channel of the APCS Discord. I should probably check. Yes, I am. So if you have questions as we go, that's the place to check. So like I said, jump into the Discord. Oh, shoot. Guys, anybody? Discord, talk channel? I could use, well, somebody. I could use somebody in the voice channel just so that I could test it. I want to test a few things. I suppose if you're stuck using only one, suppose if you're stuck using only one device, then you're stuck using only one device. Okay, whatever human is currently watching this, either jump into the Discord talk channel or say something in the chat. That's what I'm looking for. That'll do, that'll do. Hmm. Nice. And when I say nice, I use the term completely wrongly. I know, right? Well, I did say that it would be saved so that it could be watched later. So if people have questions, well, what you gonna do? It's super short anyway, and pretty quick. So I will just do this with an audience of one and have done with it. Sure, this one. That's not helpful. This one's probably not helpful either. This is a 6 in case that ever comes up. So you got your array of values. And let's say you're looking for a particular value. Let's say you're looking for a particular value. That's cool and all. The first way we can do it is through a sequential search where you just go through the array from the beginning to the end and look for the thing you're looking for. So let's say you're looking for a 7. You check the first one, is it a 7? No. You check the second one, is it a 7? No. Check the third one, is it a 7? No. Check the fourth one, is it a 7? Why, yes. And so you would return that index. So you would return a 3 in this case for that 7. As you probably guessed, the order of the sequential search is linear. Yes, you might not have to go through all of it, but you might. And so, again, the order of an algorithm isn't like specifically super specific. So because that number is less than n, we don't care about it. So it's n. O of n, or a linear search. We learned about this in CompSci 2. In fact, CompSci 2 is learning about it right now as we speak. No, I'm kidding, not as we speak. But although knowing you guys, probably as you watch this, yes. Except for one person. Thank you. If she's still here. Number 2. Nope. Okay, there is a way to shorten this up, and that would be with what's called a binary search. Now, binary search is awesome, but it first requires that you sort the array into a non-descending order. So, you know what, I'm just going to do this again. Yeah, well, I suppose that's kind of to be expected. Nope. Yeah, got plenty of 3s. Thanks a lot, dice. There we go. Oh, good. All right. The trick here is that once you have it sorted, you've got some order in your data structure. Once you have some order in your data structure, you can do some other things with it because you can approach with an algorithm that makes assumptions about the data. For example, it's in a non-descending order. So the first thing we do is we take the list and we say, hey, let's find the middle value. Well, 0 plus 7 is 7, divided by 2 is 3. So we take a look at 3. Oh yeah, what are we looking for? What should we look for? Let's look for 6. Okay. 3 the value of 3 happens to be 3. 3 is less than 6, which means 6, if it exists in this array, has to be over there somewhere. So I can ignore the rest of the array and not even look at it. So I'm chopping it out, basically, and now I'm looking at this subarray. I need to find the middle value. 3 plus 7 is 10, divided by 2 is 5. Hey, cool. Is that a value of 6? Yes, it is. So I can return a 5 as a result of that search. And it only took me 2 steps instead of 7. So because you are getting rid of half the data every time you check something, then the binary search has a big O of log base 2 of n, or just log n. Cool, huh? Hi, me, Ultimate Gamer 64. Whoever you are. All right. Where were we? All right. Well, what if you get something that you can't find in there? Like, no, there's a 3 in there. Like a 10. I'm looking for a 10. Great. So we were going to try to look for a 10 again. Hey, Lewis. I don't know why you're here. This is an AP computer science thing, but you're welcome to watch. And I even ask questions. Okay, I'm looking for a 10. So we do it again. Hey, I'm looking for a 10. I got room down here? Yeah, I do. On camera. So 0 plus 7 is 7. 7 divided by 2 is 3. So let's take a peek at the 3. The value of index 3 is 3. So that means A, we haven't found it yet, and B, it's got to be over there somewhere. So I'm getting rid of half of my, actually I probably should have cut that off here because I know this isn't. So I'm getting rid of half of my values, and now 4 plus 7 is 11, divided by 2 is 5. So I'm going to take a look at 5. 5 is also not 10, and the value at 5 is 6. 6 is also not 10, and it's less than 10, so I know that the 10 has got to be over there somewhere, so I can cut off another half of what's left. 6 plus 7 is 13, divided by 2 is 6, so I'm going to take a look at 6. Hey, look, the value at 6 is 7. 7 is not 10, and it is in fact less than 10. So I'm going to go that way to find it, to find my 10, and then also I'm going to cut that in half. Now I've only got one thing to search. I suppose I could say 7 plus nothing is 7. No, that wouldn't work. I'm just going to check to see if I've got more than one thing. The middle of 7 is 7, because your high value is 7, your low value is 7. 7 plus 7 is 14, divided by 2 is 7. So I'm going to take a look at that, and that's not 10 either, and I am out of options. So I would return -1, meaning it's not in there. All right. Can you dig it? All right. Any questions? That's pretty much it. That's the whole thing right there. Here's a question for you. Should this be recursive or non-recursive? Should we use an iterative loop, or should you use recursion for this? I will give you a moment to answer because there's like a 5-second lag. Okay. Oh, whoa, there we go. You like recursive, and you're going to do the driveway. Okay, great. Good luck. Louis. All right. Recursive. I agree. I kind of like recursive because you can just keep handing it down, and then when it pops back, it just pops straight back. And also, you always feel clever when you come up with a recursive algorithm. Non-recursive is okay too. It will be smaller as far as runtime memory usage. But again, that's important if you're running it on, say, a phone or some other very specific device like a car. But if you've got lots and lots of memory to spare, then no one cares, and recursive is fine. You can do the lab either way. I'm cool with either way when you do a binary search. All right. If there's any questions, leave them for me on Google Classroom or in the Discord. And have a happy snow day.